So now we're going to roll a die, and the result is x, but we're going to find the standard deviation of this discrete probability distribution. So in a prior example, we found the mean, and I have just moved our x's and our p of x's down here since we've already done them, and we're going to use that same information to help us find the standard deviation. So I'm now going to make a third column, which I will call the x squared column. And then I'm going to make a x squared times p of x column. All right, so x squared, we're going to go over here to all of our x's and we're going to square them. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And 6 times 6 is 36. And now I'm going to multiply this x squared column times my p of x column. Now remember that these numbers only multiply times the tops of these fractions. So 1 times 1/6 is 1/6. 4 times 1/6 is 4/6. 9 times 1/6 is 9/6. 16 times 1/6 is 16/6. 25 times 1/6 is 25/6. And 36 times 1/6 is 36/6. And then I'm going to add this column together. So let's see, we have 1/6 and 4/6 is 5/6. 5 and 9, 14/6. And 16 is 36. 55/6. And finally 55 and 36, I believe, is going to be 81/6. 91/6. Okay, so we get 91/6. All right, so I'm going to fill into my formula, and I still have my mean down here from our previous problem, and we need that. All right, so our formula says to find the variance, we're going to take the answer that we got right here, 91/6. That's going to go in the first position. That's all of this, all right? The sum of the x squared times px, exactly what we found here. And I'll put it right in there. Well, for some reason it doesn't want to go in there. Minus the mean squared, 3.5 squared. Now, a lot of people will do all of this right here and get this answer and forget to do this part right here. So just a warning, don't make that same mistake. All right, so I'm going to put this into my calculator. 91 divided by 6 minus 3.5 squared, and I end up getting 2.91666667. All right, now let's remember that this asks for the standard deviation, and I've got the variance. So I need to take the square root of this in order to get the standard deviation. And the standard deviation is always the square root of variance. So just going to take the square root of 2.91666667, and my actual answer ends up being approximately 1.7078 25128. And there we have it.